I want you to look at a flame. Really look at it. Don't just glance at the light. Stare into the movement. It creates a distinct shape. It occupies space. It has a clear boundary where the flame ends and the air begins. It dances when you blow on it. It generates heat. It consumes fuel. Sometimes it creates waste. But if you try to touch it, your hand passes right through. If you try to catch it in a jar, you capture nothing but stale air and smoke. If you stop feeding it, it vanishes from existence entirely. A rock remains a rock, whether you look at it or not. Water remains water, even if it stops flowing. But fire? Fire only exists while it is doing something. So, what is it?
Before we go any further, I want you to pause and commit to an answer. In the comments below, tell me, is fire a solid, a liquid, a gas, or is it something else entirely?
Because the answer is not just a small fact. It changes how we see reality itself. It makes us stop seeing the world as a collection of things and start seeing it as a collection of actions and processes.
Hi Questers, welcome to Quest Hut. Today, we are going to deconstruct the illusion of the flame.
To understand what fire is, we first have to understand why we are so easily fooled by it. For 2 million years, human beings have gathered around fires.
It was our first technology. It gave us cooked food, which grew our brains. It gave us warmth, which allowed us to migrate out of Africa. It gave us protection from predators. Fire is written into our DNA.
We treat it like a living companion. We say the fire is hungry. We say the fire is raging. We say the fire is dying. We personify it because it moves with the chaotic, unpredictable rhythm of life.
But this familiarity is a trap. It blinds us to the physics of what is actually happening. Let's go through the states of matter. We know it isn't a solid. Solids have a fixed shape and volume. Fire has neither.
We know it isn't a liquid. Liquids have a fixed volume, but take the shape of their container. Fire has no fixed volume. It expands and contracts based on the air pressure and fuel source.
So most people settle on gas. It looks like a gas, right? It's airy, it floats, it's made of vapor. But here is the catch. You can have a bottle of oxygen gas, you can have a balloon of helium gas, you can hold gas in a container and keep it there for 1,000 years. It is a stable substance. But you cannot have a bottle of fire. You cannot save a flame for later.
Some of you might be shouting plasma at the screen right now. And yes, if a fire gets hot enough, like the surface of the sun, or a lightning bolt, or a very intense acetylene torch, it can ionize the air molecules, stripping away their electrons and creating a plasma. But your average candle flame, your campfire, that isn't hot enough to be true plasma. It creates a few ions, sure, but scientifically, it doesn't meet the full criteria.
So if it's not solid, liquid, gas, or plasma, what is left? The answer is that fire is not matter at all. Fire is what happens to matter. Fire is not a noun. Fire is a verb. It is a sensory experience caused by a violent chemical divorce. Let's look at the secret life of a candle. When you light a candle, you assume the wax is burning. But take a closer look. If you touch the side of a candle, the wax is cold and solid. Solids don't burn. If you look at the pool of melted wax near the wick, it's hot, but it's not flaming. Liquids don't burn. For fire to exist, matter must first liberate itself from its physical form. When the match touches the wick, the heat melts the solid wax into a liquid. Then, capillary action, the same force that pulls water up a tree root, pulls that liquid wax up the cotton wick. As it gets closer to the heat source, that liquid gets so hot that it boils. It turns into a gas. It is this invisible gas, this vaporized wax, that is actually burning. But burning is a lazy word. We need to go deeper. We need to look at the atoms. Wax is a hydrocarbon. That means it is a long chain of carbon atoms holding hands with hydrogen atoms. They are locked together in a stable relationship. They are happy. They are chemically satisfied. But they are also holding on to a secret. Stored inside the bonds between these atoms is energy. ancient energy. Energy that was captured from sunlight by plants millions of years ago, processed by animals or geological pressure, and locked away in this wax.
These carbon and hydrogen atoms are like a compressed spring, waiting to snap.
Enter oxygen. Oxygen is the homewrecker of the periodic table. Oxygen is aggressive. It desperately wants to bond with other elements. When the heat from the match hits those wax gas vapor molecules, it gives them enough energy to break their old bonds. The carbon lets go of the hydrogen. The hydrogen lets go of the carbon.
For a split second, chaos reigns. The atoms are free.
And then the oxygen strikes. The oxygen atoms snap onto the hydrogen atoms to form H2O, water vapor. The oxygen atoms snap onto the carbon atoms to form CO2, carbon dioxide. This is the critical moment. This is the magic trick. It takes energy to break the old bonds, but when the new bonds form with the oxygen, they release energy. A lot of energy. Much more energy than it took to break them. It is a net surplus. The spring has finally unsnapped. The energy that was trapped in the wax for millions of years is suddenly dumped into the universe all at once. It explodes outward as vibration, as heat, and most importantly, as light.
This is what you are seeing. You are not seeing a thing. You are seeing the visible footprint of a chemical reaction. You are seeing the exact moment that matter rearranges itself. The flame is just the region of the atmosphere where this violence is taking place.
But this brings us to the next layer of the mystery. We know why it gets hot. That's the energy release. But why does it glow? Why does it produce light? And why does it have colors?
If you look at a candle flame, you see yellow, orange, maybe a little blue at the bottom. If you look at a gas stove, you see bright blue. If you throw copper powder into a fire, you see green. If you burn strontium, you get deep red. Why?
There are actually two completely different physical processes happening in a flame, and they tell two different stories.
The first story is about quantum mechanics. It's the story of the blue flame.
Look at the bottom of a candle or the ring of a gas stove. That blue light is the cleanest part of the fire. Here, the fuel is mixing perfectly with the oxygen. The reaction is efficient. The atoms are breaking and reforming without any leftovers. When these atoms react, the electrons, the tiny particles orbiting the nucleus, absorb the excess thermal energy. They get excited. Imagine a ball sitting at the bottom of a staircase. If you kick it, it jumps up to a higher step. That is the electron jumping to a higher energy orbital. But electrons are claustrophobic. They don't like being in high energy states. They are unstable. So almost immediately, they fall back down to their original step. And here is the rule of the universe. Energy cannot be created or destroyed. So when the electron falls from the high step to the low step, it has to do something with that extra energy. It can't just keep it. So it throws it away. It ejects a packet of energy, a photon. This is light. Because the energy gaps in carbon and hydrogen reactions are very specific, the light they emit is a very specific color, blue. This is called chemiluminescence. It is the light of chemical change. It is the signature of the atoms themselves singing as they rearrange. But what about the yellow and orange? This is where things get messy. And to understand this, we have to look at a wood log. A log in a fireplace is essentially a giant, complex candle. It is full of carbon. But a log is dense. It's hard for oxygen to get deep inside the wood structure to burn every single atom of carbon perfectly. The reaction is dirty. It's incomplete. In both the candle and the wood log, the hydrogen burns easily, but a lot of the carbon gets left behind. These leftover carbon atoms clump together to form tiny, microscopic specks of soot. They are solid particles. They are smoke. But they are trapped inside the inferno of the flame. As they float upward, the heat roasts them. They get hot, incredibly hot. And when solid things get hot, they glow. Think of a blacksmith heating a horseshoe. First, it glows red, then orange, then yellow, then white. The yellow part of a candle flame, or the comforting orange glow of a campfire log, is actually a cloud of millions of tiny, glowing solid particles of carbon. They are microscopic embers floating in the sky. They aren't reacting chemically anymore. They are just radiating heat as light. So when you look at a fire, you are seeing two universes of physics at once. At the bottom, in the blue, you are seeing quantum mechanics, electrons jumping orbitals. At the top, in the yellow and orange, you are seeing thermodynamics, solid matter glowing with heat. And this brings us to the other colors. What if you see green, or pink, or red? This brings us back to the quantum side. Remember the electron jumping down the staircase? Every element in the universe has a unique staircase. The steps are different heights.
If you burn copper, the electrons fall down a specific distance that releases green photons. If you burn lithium or strontium, the electrons fall a distance that releases red photons. If you burn sodium, like in street lamps or table salt, you get a bright, intense yellow, but a different yellow than the soot.
This is how fireworks work. They're just gunpowder mixed with specific salts to paint the sky. This is how astronomers know what stars are made of billions of miles away. They look at the color of the light. The fire is literally revealing the identity of the matter it is consuming. It is a chemical fingerprint written in light. Now, I want to take this concept one step further. I want to bring it home. We have established that fire is a chemical reaction, where fuel meets oxygen to release trapped energy. If you take a deep breath right now, you are inhaling oxygen.
If you ate a meal today, you put fuel into your stomach.
Inside your body, at this very moment, in every single one of your trillions of cells, a reaction is taking place. Your cells are taking the glucose, the fuel, and combining it with oxygen. They are breaking the chemical bonds. They are rearranging the atoms, and they are releasing energy.
The waste product? Carbon dioxide and water, exactly the same as the candle. The output? Heat. That's why your body is 37 degrees Celsius. Biologically speaking, you are on fire.
The process is called cellular respiration, but chemically, it is almost identical to combustion. The only difference is the speed. In a candle, the reaction is uncontrolled. The energy dumps out all at once, creating temperatures of 1,000 degrees. It is chaotic violence. In your body, the reaction is controlled. Your cells have tiny machines called enzymes that act like gatekeepers. They force the reaction to happen in tiny, manageable steps. Instead of an explosion, you get a slow, steady burn. Instead of a flash of light, you get a molecule called ATP that powers your muscles. But make no mistake, the chemistry is the same. The equation is the same. Life is just a fire that learned how to conserve its fuel. We are all just slow-burning candles walking around the surface of the earth. This perspective changes everything. It changes how we see the universe. We tend to think of the world as being made of static, solid things. But fire teaches us that things are just temporary illusions. The wood in the fireplace looks solid. It looks permanent. But the fire proves that the wood was just a battery, a temporary storage container for sunlight and gas. The fire doesn't destroy the wood. It just releases it. It lets the carbon go back into the air as CO2, and it lets the energy go back into the room as heat. Nothing is destroyed. Everything is transformed. So let's go back to the opening question. Is fire a solid? No. Is it a liquid? No. Is it a gas? No. Fire is a performance. The flame is not an object. The flame is a window. It is a ghost. It is the spirit of the wood leaving the physical realm. It is the moment of transition. So the next time you light a candle, or sit by a campfire, or watch a rocket launch into the sky, don't just look at the light. Look at the process. Remember that you are not looking at a thing. You are looking at a reaction. You are watching atoms dance, break, and reform. You are watching the fundamental gears of the universe turning in real time. And perhaps, if you are very quiet, and you feel the warmth on your face, you will realize that the same fire burning on that wick is burning inside of you, keeping you alive, one breath at a time.
Fire isn't just something we use. In a very real way, fire is what we are.
Thank you for watching. If this video sparked a new thought in your mind, light up the like button and subscribe to Quest Hut. We don't just look at the world here, we take it apart to see how it works. I'll see you in the next one.